For a long time, people have wondered, are we alone in the universe? It's a big question that goes beyond our little blue planet, making us think and wonder about what's out there. This curiosity has led scientists, astronomers, and fans to explore what's beyond our stars. From thinking about aliens in science fiction to actually studying the possibilities of life beyond Earth, we've come a long way. Discoveries like planets outside our solar system, exoplanets, weird microscopic life on our own planet, and the huge size of the universe have changed how we see things. We've even started looking for signs of life on Mars and under the ice on one of Jupiter's moons, Europa. But as we look at the huge space around us, some people are starting to question if we're really all alone. There are more than 1,500 planets outside our solar system, extrasolar planets, but only a few of them meet the requirements for supporting smart life, like having a stable environment, water, and the right size and makeup. Even though there are so many stars and galaxies, using a famous formula, the Drake equation, gives us surprisingly low estimates for finding intelligent life. Thinking about our place in the universe, some say it's a bit much to believe that Earth is the only place with smart life that can travel between stars. What if other civilizations, smarter than us, have already visited or are watching us? Could those mysterious things we see in the sky be connected to this? Asking these questions gets us thinking about where we really fit in the big picture of the universe. And here comes the Fermi paradox. 1950. Enrico Fermi and his colleagues were discussing the existence of alien life over lunch. The question that Fermi asked the table became infamous in its simplicity. Where is everybody? The room fell silent because, well, nobody had an answer. Originally, the question was meant to attack the idea of interstellar travel, the possibility of which Fermi wasn't confident. But the question remains, if there were civilizations scattered across the stars by the billions, why haven't we heard from them? It is from these questions, the Drake equation and the Kardashev scale, that the true paradox was born. The Milky Way is about 10 billion years old and 100,000 light-years across. If aliens had spaceships that could travel at 1% of the speed of light, the galaxy could have already been colonized 1,000 times. Why haven't we heard from any other life? That very question is the Fermi paradox. It has sparked numerous explanations for the silence we've been experiencing. Some scientists think that the silence is the product of something they've coined the Drake equation, an evolutionary wall impermeable to most life. The Drake equation is one of the most famous equations in astronomy. A lot of effort has been poured into solving it, but it's unsolvable. So why do we bother? Firstly, what is the Drake equation? Effectively, it is a way to estimate the number of intelligent extraterrestrial species in the Milky Way galaxy, or local group, or universe, etc. In other words, are we alone on this journey through the cosmos or not? The equation looks like this: N, E, Argir, FP, Na, FL, FFI, FC, L. Looks complicated, right? It's actually pretty straightforward once we look at the individual parts of the equation. Remember, we're not doing any actual math, just looking at the concept of the equation. N equals 2, the number of intelligent civilizations in our galaxy with which we could communicate. And R equals 2, the average rate of star formation in our galaxy. FP equals 2, the fraction of those stars that have planets. NE equals 2, the average number of planets that can potentially support life per star that has planets. FL equals 2, the fraction of planets that could support life that actually develops life at some point. FI equal 2, the fraction of planets with life that actually go on to develop intelligent life, civilizations. FC equals 2, the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. L equals 2, the length of time for which such civilizations release detectable signals into space. Let's leave aside the first few parameters. They can be at least somewhat estimated. The last 4 variables are all completely unknown. A fraction of planets that support life that actually develop it at some point. We have no way of knowing this without actually finding life first. We currently have a sample size of 1. Even within our solar system, there is vigorous debate about whether Mars, Europa, a moon, and others currently have life, or have had it in the past. There is simply no way to estimate this parameter until we find more life. Even then, it won't be easy to do. We would also have to have a reasonable estimate. Economist Robin Hanson first proposed the Great Filter in the late 1990s. It's the idea that even if life forms abundantly in our Milky Way galaxy, each extraterrestrial civilization ultimately faces some barrier to its own survival. The barrier might come from without, for example, an asteroid striking a planet and wiping out all life forms. Or it might come from within, for example, all-out nuclear war. Hanson proposed that a great filter might be at work within our Milky Way galaxy. He argued that from what we can see here on Earth, life expands to fill every niche. And so, he argued, we should see signs of intelligent life beyond Earth in nearby star systems, perhaps even in our solar system. But we don't see this. But here comes the big question. Is humanity facing a great filter? Humanity may be facing a great filter of our own making, and one that other intelligent civilizations in the galaxy have faced and failed to withstand. Perhaps it's no surprise that the technological advancements humans have achieved might ultimately lead to our undoing. Perhaps that's nature's way. It seems as though nearly every great discovery or invention, while pushing back the borders of our technological ignorance, is all too quickly and easily turned to destructive ends. Examples such as splitting the atom, biomedical innovations, and resource extraction and consumption come to mind with disconcerting swiftness. Still, some have suggested artificial intelligence, AI, as yet another factor, which, pending substantial technical hurdles, may yet have its chance to prove friend or foe. The Great Filter poses some challenges to humanity, which include unchecked population growth, nuclear war, pathogens and pandemics, asteroid and comet impacts, and most especially climate change. So you see, there's not just one possible Great Filter for Earth, but many. Any one of them could be our downfall. Scientists are suggesting something that sounds simple on its face but is, apparently, hard to do. That is, in order to avoid the Great Filter, humans must work together and recognize the big picture. History has shown that intraspecies competition and, more importantly, collaboration have led us toward the highest peaks of invention. And yet, we prolong notions that seem to be the antithesis of long-term sustainable growth. Racism, genocide, inequity, sabotage, the list sprawls. Meanwhile, we continue to look outward, peering at the dark depths between the stars, hoping for a sign that we aren't alone in the universe. Ultimately, our quest to find life beyond Earth is part of trying to understand life on our planet and where we fit in. In the deepest sense, the search for extraterrestrial intelligence is a search for ourselves. But here is the bottom line. Scientists say the reason we haven't found intelligent civilizations in the galaxy is that they may not have survived the Great Filter. And they say we may be facing down our own Great Filter. However, one solution seems to be darker than the others, and that is the dark forest theory. The Milky Way galaxy has 200 billion stars and perhaps 100 billion planets. If even a small fraction of those planets harbored life, and even if only a pathetic scattering of those planets had life forms that became intelligent, our galaxy would be teeming with alien civilizations, some of whom would be either looking for us or discoverable for at least a little while. The number of alien civilizations the galaxy should have can be determined by an equation, the Drake equation, that turns the above factors into variables. When you plug them into the formula, you find that there should be at least 20 civilizations in our cosmic neighborhood. This makes the fact that we have yet to find any other life in the cosmos almost shocking when you think about it. The seeming discord between how many advanced civilizations ought to be in space and the lack of evidence for any is known as the Fermi paradox. It has led to dozens of hypotheses and potential solutions over the last few decades. Many of the solutions aim at one of the variables in the Drake equation and try to make the supposed number of civilizations lower, so it is more reasonable for us to not have met anybody yet. Some propose that life starting at all is rare. Others suggest that the development of intelligence is the bottleneck, and others still posit that most civilizations would live for a short time before blowing themselves up, or, conversely, never even manage to invent the radio. The dark forest solution explains why we haven't heard from aliens by positing that they are purposefully keeping quiet. The reasoning is laid out best in the science fiction novel The Dark Forest by Liu Cixin. The plot of the book, the second in a series, concerns questions of how to best interact with potentially hostile alien life. According to the novel, all life desires to stay alive. There is no way to know if other life forms can or will destroy you if given a chance. Lacking assurances, the safest option for any species is to annihilate other life forms before they have a chance to do the same. Since all other life forms in the novel are risk-averse and willing to do anything to save themselves, contact of any kind is dangerous, as it almost assuredly would lead to the contacted race wiping out whoever was foolish enough to give away their location. This leads to all civilizations attempting to hide in radio silence. The universe is a dark forest. Every civilization is an armed hunter stalking through the trees like a ghost, gently pushing aside branches that block the path and trying to tread without sound. Even breathing is done with care. The hunter has to be careful, because everywhere in the forest are stealthy hunters like him. If he finds another life, another hunter, angel, or a demon, a delicate infant to a tottering old man, a fairy, or a demigod, there's only one thing he can do: open fire and eliminate them. It's a bit like the prisoner's dilemma, really, and the concept is based on applied game theory. But how plausible is this theory? This theory has the advantage of only affecting one of the variables in the Drake equation, and affecting the one that is the most open to speculation. It also doesn't require us to make broad assumptions about how all alien civilizations behave. A single advanced race that acts this way would be enough to cause the observed situation. This would also explain why we haven't found any mundane alien radio signals despite a century of being able to pick them up. Just as we accidentally send our radio signals, meant for us, out into space, another civilization would be likely to as well. One possible reason for this is that other civilizations are so fearful of being detected that they purposely avoid sending out any radio evidence of their existence. It does, however, assume that other species have a similar risk aversion level and reasoning process as we do, or that there really is one civilization out there killing off anybody they think can harm them. This is a big assumption. The seeming discord between how many advanced civilizations ought to be in space and the lack of evidence for any is known as the Fermi paradox. It has led to dozens of hypotheses and potential solutions over the last few decades. Many of the solutions aim at one of the variables in the Drake equation and try to make the supposed number of civilizations lower, so it is more reasonable for us to not have met anybody yet. But why is this theory dark? We've been screaming our existence to the cosmos for almost 100 years now. Any aliens within a 100 light-year radius of us would be receiving a barrage of radio signals from our direction. If we had reason to avoid letting aliens know about us, as Stephen Hawking thought we did, we might have a problem. Why haven't we heard from aliens yet? If this solution is correct, they are purposely hiding in the darkness of space for fear of death. Should we stop broadcasting our existence to the universe too then? Or would alien life be a little nicer than we've been in our history? But let's finish with a slightly less gloomy outlook, because it's not as though the dark forest theory is definitely correct, and there are plenty who go against it. Perhaps the strongest counterargument is that it doesn't allow for much by way of cooperation. In the dark forest universe, every single hypothesized alien species is solely out for itself, and is hell-bent on removing everything else from its path. But for that society to have become advanced enough to even attempt interstellar missions at all, it's a good bet that first, it will have to have learned the value of cooperation within itself. So, why wouldn't it prefer to at least try to peacefully communicate with another species, rather than just blasting it away by default? Perhaps the strangest thing is that the dark forest theory doesn't allow much time at all for first contact. It does provide one solution to the Fermi paradox, and it implies that there could be countless alien civilizations out there. It's just that they're all tentatively hiding away from each other, bidding their time for the best moment to strike. But when it comes to actually crossing paths with and recognizing extraterrestrial species, the suggestion is that it would all be over before it had even begun. It's an idea that forces us to consider our own position and impact on the universe around us. Should we, the citizens of Earth, take more notice of the dark forest theory? Or could it be that we've already been spotted by some far-off group, and we're doomed anyway? So, in the meantime, why worry? Or is there yet another better solution to the Fermi paradox? One that doesn't require quite so much existential paranoia. In exploring the Fermi paradox, we've dug into various and sometimes controversial ideas that challenge what we think about the possibility of alien civilizations. We've talked about the Great Filter, which looks at why we haven't seen signs of intelligent life nearby, and the dark forest theory, suggesting that aliens might be staying quiet to avoid potential dangers. To sum it up, the Fermi paradox captures our interest by telling a complex story involving technology, culture, potential extraterrestrial observers, and the nature of life itself. The debates around these ideas encourage us to rethink what we assume, sparking ongoing exploration and discussion about our role in the vast universe. The universe has intrigued humanity for ages, and there's a call for more exploration and scientific inquiry into the existence of extraterrestrial life. Thanks for watching, and until next time.